Okay, in this section, the directions say to write the partial fraction decomposition. And we did this a few chapters back. But basically, you're going to clear this whole fraction, or clear this whole equation of the denominators, or multiply every single part of the equation by the common denominator, which is x, x minus 1, and x plus 3. And when you do that, you get 1 on this side. When you multiply this one, and again, remember I'm multiplying the whole fraction by all three of these things, x, x minus 1, x plus 1. When that's multiplied out, it is this. So if I multiply this times this fraction, those cross out. If I multiply this times this fraction, let me just write it up here. So I'd have an x minus 1, and an x plus 1, times this fraction. Do you know what cancels out? Right, the a. So I'm left with, the x. So I'm left with a times x minus 1, x plus 1. Now, when I multiply this whole thing again times this next part, the x minus 1 cancels out. So I have b times the x and the x plus 1. And then if I multiply this whole thing times this, the x plus 1 cancels out. So I have c times x and times x minus 1. And that's the first step in the partial fraction decomposition. I hope this is bringing back some memories of when we did this in the past. All right, the next step, multiply everything out. So we still have our 1 here. We still have our a. Let's multiply these two. That would be x squared, no middle term, minus 1, plus b. Let's multiply the next one, x squared plus x, plus c times x squared minus x. All right, almost there. 1 equals ax squared minus a plus bx squared plus bx plus cx squared minus cx. Do you remember what we had to do next? We grouped all the x squareds together, all the x's together, and all the terms that did not have any x. Do you remember that part? All right, let's do that. So when I get all the x squareds together, I'm going to have a plus b plus c all times x squared. So I put them together and I factored it out to save a step. All right, now let's look for the x terms. So what am I going to have there? Plus b minus c times x. Again, I'm going to factor out the x. Am I going too quick? That first would be written as bx minus cx. Factor x out of both. All right. What do I have left? Just a minus a. Okay. Okay, I need to continue solving this. And the interesting values that I need to use for x when I'm solving this come from looking at the original fraction. The important values to use, and I'm just going to write them right here, are x equals 0, x equals 1, x equals minus 1. Why are those values important? Why are those the values I use? Those are the values that make the bottom of the fraction 0 in certain cases. So this part would be 0, or this part would be 0, or this part would be 0. So what happens when I start doing that? Well, if I let x equals 0, look at what happens. Do you see that when x is 0, this part disappears, this part disappears? So I have, all right, let's write that down. Let x equals 0, and I get 1 equals negative a, or a equals negative 1. So I'm getting the partial fraction solved here. I know the first number up here is a negative 1. You follow that? Okay, what am I going to do next? I'm going to let x equal 1 and see what that gives me. So let x equal 1. What do we get? 1 equals, when x is 1, 1 squared is 1, so I have a plus b plus c. When x equals 1 here, I get 1 times b is b minus c. 1 times minus c is minus c minus a. Now, when I start adding like terms, look what happens. A and minus a, gone. C and minus c, gone. So I have here 1 equals b plus b, 2b. Solve that. Finish solving that. And what do I get? I get b equals 1/2. Okay, one more part here. Let x equals -1. So when x is -1, let's start off with 1 equals -1 squared is 1. So this is a plus b plus c. -1 times b minus b. -1 times minus c plus c minus a. And then again, combine like terms. The a's cancel, the b's cancel, so I get 1 equals 2c, so 1 equals 2c, so c equals 1/2. So for my partial fraction decomposition, I now have the a, the b, and the c. So I can just plug them in. Let me clean up the board and I'll show you what that looks like. Okay, so now that I solved for a, b, and c, I can rewrite this problem as 1 over x to the third minus x equals -1 over x plus 1/2 over x minus 1 plus 1/2 over x plus 1. Now, you know you can't leave the answer like that, right? Because I have a fraction within a fraction, complex fraction, not cool. So what you can do is you can factor out a half. If I take a half from here, leaves a 1, take a half from here, leaves a 1, take a half from here, it leaves a 2. So, so let's do that. So I'm going to call the final answer 1/2 times -2 over x plus 1 over x minus 1 plus 1 over x plus 1. And there you have the partial fraction decomposition, and we solve for a, b, and c. I'm sure you can do this.